Okay, there's more than one method to solve simultaneous equations. The method I'm going to show you now is called solving them by elimination. So what it means is that we're going to eliminate one of the variables. So in the first question here, we're either going to eliminate x or eliminate y. So let's start off by listing those two equations. So equation 1 is 3x minus 2y equals 20. And equation 2 is x plus 2y equals 4. Now, the idea is that you either add or subtract the two equations to eliminate one of the variables. Before you can do that, you have to make sure that the coefficient of the variable, so the number in front of it, is the same in both equations. Now, in this example, they both have a 2. One of them is -2 and one of them is +2. So you've got to think about how would I eliminate them? Would it be better to add the 2 or would it be better to subtract the 2? So if I add them, that means I would have -2 plus 2. And when I work that out, that's 0. So that would eliminate my term with y. If I wasn't sure and I tried negative or subtract, I would have -2 subtract 2. That gives me -4. So you've got to be really careful and think about whether you should be adding or subtracting the equations. So I'm going to add those two equations. By adding those two equations, what I'm going to get is 4x. This becomes 0, so I don't need to write that down. They're eliminated. And 20 plus 4 is 24. So essentially what I'm doing is I'm adding the like terms. Okay. Alright, then I've got a nice equation. I've just got 4x equals 24. Divide by 4 to get x, and I get 6. Alright, now this part of the solution is the same as when we solve it by substitution. We take that answer and we substitute that answer, x equals 6, into one of the other equations. Doesn't matter which one, try and pick the one that's going to be a bit simpler to solve. I think probably the second one is going to be a little bit easier. So wherever I see x, first of all let's write down the equation. X plus 2y equals 4. So where I see x, I'm going to replace it with 6. So 6 plus 2y equals 4. Subtract the 6, 2y equals -2, and divide by 2, so y equals -1. So my solution to this pair of equations is x equals 6 and y equals -1. Alright, let's try another example. So example 2, I've got equation 1, which is 4a minus 3c equals 1, and equation 2 is 2a minus 3c equals 2. So my a's have different coefficients, but my c's have the same coefficient. They're both -3. So let's think about whether we should add or subtract. -3 plus -3. Remember that when they're together like that and they're different, it becomes subtract. So -3 minus 3 is -6. -3 minus -3, that will become plus. So -3 plus 3 is 0. So if I want to get 0, it means that I'm subtracting the two equations. Alright, I need -3c minus -3c. One way that you can remember is if they're the same, then you subtract. If they're different, you add. Okay, so these are the same sign, so I need to subtract the two equations. So, by doing that, 4a minus 2a is 2a, -3c minus 3c is 0, and 1 minus 2 is -1. So my equation is 2a equals -1. Divide by 2, so a equals -1 on 2. Alright, so I've got my answer for A, I need to get an answer for C. So I'm going to substitute A equals negative half into one of the other equations. I'm just going to put it into equation 1. So I've got 4A minus 3C equals 1. Where I see A, I put in negative half. So 4 times negative half minus 3C equals 1. 4 times negative half is negative 2. Minus 3C equals 1. Add the 2. So that becomes negative 3C equals 3. And divide by negative 3 to get negative 1. So finally my solution is A equals negative half and C equals negative 1. Alright, we're going to go through one more example. This is probably the most difficult of the examples. Alright, so again, write down our two equations. We've got 5p minus q equals 11. And our second equation is 2p plus 3q equals 1. Now, the problem with this question is, when we look at it, we've got 5p and 2p, they're not the same. We've got negative 1q and positive 3q, they're not the same either. So it's not easy to eliminate something straight away. We've got to do something to one of those equations so that we get the same coefficient for one of the letters. So looking at that, I think it's going to be easiest to make the coefficient of q the same. And I can do that by multiplying my first equation, multiplying all of that by 3. Because if I multiply negative q by 3, I get negative 3q. Alright, so I've got another equation here. I'm going to write this down as equation 1a or 1b. Let's call it 1b. So timesing everything by 3, I get 15p minus 3q equals 33. Okay, so now I've got the same coefficient for q. So I'm just going to write those two equations out again. So that's 1b, and 2 was 2p plus 3q equals 1. Alright, so am I going to add them or am I going to subtract them? Remember that they're different. If they're different, to get 0, I should add the two equations. So adding those two equations, 15p plus 2p gives me 17p. Negative 3q plus 3q gives me 0, and 33 plus 1 gives me 34. Then I divide by 17, so p equals 2. Alright, so I've got p equals 2. Substitute that in to one of your original equations. Alright, I'm going to put it into the equation 1. So equation 1 was 5p minus q equals 11. So where I see p, I'm now going to put in 2. That then gives me 10 minus q equals 1. Subtract 10, so negative q equals negative 9. If negative q equals negative 9, then positive q equals positive 9. Alright, so my solution is p equals 2, q equals 9. Alright, now it's your turn to have a try of those, so you can try exercise 409, all of those questions.